Awaiting visual confirmation.
All right.
We have Francisco Diego, a lecturer of physics and astronomy at University College of London. Diego, welcome.
It's a pleasure.
You heard those cheers go up at NASA. What excites you most about this accomplishment?
Well, it is quite an accomplishment. You remember, we are talking hundreds of millions of kilometers away. Sending this spacecraft is going to target this rock, which is only less than 200 meters across, the size of a football stadium, and hit it dead in the center, in the front, actually, as it goes around the orbit. It was quite an achievement of planetary navigation, if you like. So that was part of the problem. Yes, you were asking something.
Oh, no, that's okay. I was just curious, when you look at the specs on this asteroid and you find out that it was only a few hundred meters long, I mean, very tiny in space terms, as these things could approach the Earth and once they encounter the Earth's atmosphere, would they not burn up at that size?
Well, yes, part of the object will burn, but most of that will survive. And very famously, the extinction of the dinosaurs, and 75% of life on Earth at that time, 64 million years ago, was due to such a collision. Mind you, that asteroid was 10 kilometers across, and that was really, really huge and produced a global catastrophe. In this case, we have something which is a beautiful experiment because the selected target has been extremely important. First of all, it's relatively close to the Earth. I mean, quite safe distance anyway, 10 million or 11 million kilometers away when this thing happened. But second, it's a double asteroid. So the little asteroid, the Dimorphos, goes in orbit around the Didymos, and it goes in orbit in 12 hours. So by targeting the little one and moving that asteroid a little bit in that particular orbit, then we can change the orbit. In this case, the head-on collision will slow down this Didymos, and it will go down Dimorphos. It will go in a smaller orbit. It will increase the speed, and it will reduce the period. We can observe the period because, in another coincidence, we can see the asteroid going in front of the other one. We can see the change of luminosity, and we can tell that that period is 12 hours at the moment.
Yeah.
With this experiment, the period will be reducing because the asteroid is going to be faster in a smaller orbit, and it will go, for example, 11 hours and 50 minutes or something like that, which is what the telescopes are going to confirm in the next few weeks.
Now, when space stories hit the headlines for the average consumer, the big topics like Mars tend to get all the attention. But to an astrophysicist, the fact that there are countless asteroids out there, how big a worry is that? Is that threat of one of those hitting the Earth something that keeps you guys up at night?
Well, the threat is always there. It's not that much, not that high that we keep awake at night, but we have a whole set of telescopes surveying the sky, looking for threatening asteroids. There is a good catalog of asteroids that are on the and there is none that are in collision course with the Earth at the moment. But as you say, there are so many asteroids there. The little ones, there are too many. There are plenty of them. The smaller they are, the more numerous they are, and they are more difficult to locate. But the bigger ones, of course, were very well cataloged. This experiment is going to help a lot in order to plan to new experiments in the future to produce proper protection to the Earth. But this is important for the next centuries to come, where these destructive asteroids may materialize in the next few hundred years.
Yeah, I'm still amazed that humans can do this at all. It just boggles my mind. All right. Diego, thanks so much for joining us.
It's a pleasure.